The Fourier transform is widely used in various fields, including signal processing, communications, image processing, audio analysis, and many others. Bismillah ar-Rahman ar-Rahim. In this simple video, I'm gonna recap the properties of Fourier transform. There are 9 properties which are as follows. Linearity. The linearity property of Fourier transform states that the Fourier transform of a weighted sum of two signals is equal to the weighted sum of their individual Fourier transforms. In other words, if x1 of t and x2 of t are two signals with Fourier transform x1 of omega and x2 of omega respectively, then for any two constants a and b, the Fourier transform of ax1 of t plus bx2 of t is equal to ax1 of omega plus bx2 of omega. Time shift. The time shifting property of Fourier transform states that if signal of x of t is shifted by t node in the time domain, then its frequency spectrum is modified by a linear phase shift of slope minus omega t node. Therefore, if x of t has a Fourier transform x of omega, then the Fourier transform of x of t minus t node is equal to e power of minus j omega node x of omega. Frequency shift. Frequency shifting property of Fourier transform states that the multiplication of time domain signal x of t by an exponential e power of j omega node t causes the frequency spectrum to be shifted by omega node. Therefore, if x of t has a Fourier transform x of omega, then the Fourier transform of f of e power of j omega node t x of t equal to x of omega minus omega node. Scaling. The time scaling property of Fourier transform states that if a signal is expanded in time by a quantity a, then its Fourier transform is compressed in frequency by same amount. Therefore, if x of t has a Fourier transform x of omega, then the Fourier transform of x of at is equal to 1 over absolute limit of a x of omega over a. Frequency differentiation. The frequency differentiation property of Fourier transform states that the multiplication of a function x of t in time domain is equivalent to the differentiation of its Fourier transform in frequency domain. Therefore, if x of t had a Fourier transform x of omega, then the Fourier transform of t x of t is equal to j d by d omega x of omega. Time differentiation. The time differentiation property of Fourier transform states that the differentiation of function x of t in the time domain is equivalent to the multiplication of its Fourier transform x of omega by a factor jw in the frequency domain. Therefore, if x of t has a Fourier transform x of omega, then the Fourier transform of dx of t by dt is equal to jw multiplied by x of omega. Convolution. The convolution property of Fourier transform states that the Fourier transform of the convolution of two signals is equal to the product of their individual Fourier transforms. In other words, if x1 of t and x2 of t are two signals with Fourier transforms x1 of omega and x2 of omega respectively, then the Fourier transforms of their convolution x1 of t multiplied by x2 of t is equal to x1 of omega multiplied by x2 of omega. Duality. The duality property of Fourier transform states that if a signal x of t had a Fourier transform x of omega, then if we form a new function of time that has a functional form of the transform x of t, it will have a Fourier transform x of omega that has the functional form of the original time function, but is a function of frequency. Parseval identity. The Parseval identity property of Fourier transform states that the energy content of signal x of t is equal to the energy content of its Fourier transform x of omega. In other words, if x of t had a Fourier transform x of omega, then the energy content of x of t is given by the following formula. Finally, if you like this recap, please let me know to solve some example of these properties.